All right, algebra 2, here goes nothing. All right, so this is on page 26. Again, these are the four graphs that you guys glued into your notebook. We're going to call this quadratic. All right, wrong pen. Quadratic transformations. Now that last chapter, we covered this a lot, talking about transformations. So we're going to basically take a look at the same thing from a quadratic standpoint. So a lot of these things you guys have seen before, but again, this is kind of review. But it's also kind of some tips and shortcuts on how to navigate graphing and figuring out important parts of the graph. Okay, so the first thing we want to start with is the parent function of a quadratic. Okay, parent function of a quadratic is just f of x equals x squared. Okay, so let's make a table for that. So a quick little table here, our x, y's, and y values. We'll do about 4 down. So first let's start with 0. If I plug in 0, 0 squared is 0. I plug in 1, 1 squared is 1. I plug in 2, 2 squared is 4. I plug in 3, 3 squared is 9. Okay, and let's go ahead and plot those on the graph. So I got 0, 0, 1, 1, 2, and 4, and then 3, and 1, 2, 3, 4, 5, 6, 7, 8, 9. And if you remember, parabolas are symmetrical, so it'd basically be the exact same thing on the other side. So I don't even need to complete another continue the table because I know that it's symmetrical going this way. So that's our parent function. Try to make our u nice and straight. All right, so now let's talk about transforming that. Okay, the first one I want to look at is what if I took this same function, let's do it on the same graph there, and well actually it's a new function, so we're not going to use f, let's say g of x. We're going to take that and then put a 2 on the outside. Now if you remember, a 2 on the outside, that is that's a vertical change. Okay, and remember it's not lying to you when it's on the outside, so this is called a vertical stretch. But let's see what that looks like in a table. 1, 2, 3, 4. Okay, 0 goes in, still 0. 1 goes in, 1 squared is 1 times 2 is 2 this time, before it was 1. And then I put 2 in, 2 squared is going to be 4, times 2 is 8 this time. And then 3, I could put that in, that's 3 squared is 9, times 2 is 18. Okay, now let's compare the first values to the second values. So when I plugged in 0, I still got 0. When I plugged in 1, it became 2. That's twice or double the same value. I plugged in 2 again. I got 4 here, 8 here. Again, that's double. I plugged in 3, I got 9. Well, 18 is double, and if you notice, that number is 2. So it's basically going to double your y values. So if I was to draw this out, this will be our g of x in brown. Okay, so now I have 0, 0 in the middle again. 1, at 1 it goes up to 2, and at 2 it goes up to 8 this time, all the way up here. And then the last point I can't even graph, it's too far up. And I'll repeat the same thing on the other side. So remember, it's vertically stretching it, and it's making it, essentially it's making it skinnier. Now let's compare the first values to the second ones. If you notice, the first one, which was 1, it went up 1. Okay, then the second one, the one that was 2, it went from 4 up to 8. So it doubled the size, doubled the height from the x-axis. So it's going to follow this pattern every time you change that number in the front. Okay, so now let's say we're going to go into the next graph here. We're going to take that same function. Oops, sorry. Again, I messed up. We want h. We'll do h of x this time. And we're going to put 2 times, and let's actually put it almost like in a vertex form looking equation. So x minus 4 and then minus 3. Okay. All right. So now I could draw the table. However, I know that when it's in this form, it tells me the vertex right away. So I know that my vertex is positive 4, because remember x is a liar, and negative 3. So let's go ahead and just plot that on there. And I'm going to go ahead and use the blue. All right, so 4, right 4, down 3. There's our vertex. Now remember that pattern, it follows. If based on the parent function, right? If I go 1 to the right, it goes up 1. If I go 2 to the right, it goes up 4. If I go 3 to the right, it goes up 9, following this same original pattern. Except now, this time I have a 2 in the front. Okay, so that means it's going to follow this pattern. So if I go start here, then that means when I go to the next point, I go to the right, but then up 2. And then if I go to the right one more time, I'm going to go up 8, count 8 from basically from the vertex. Up 4 plus 4, 8. And the last one would be 18, but again, that doesn't fit. And then obviously reflect it over to the other side, and then make your U. So I didn't even need a table for that case. I just know that if I put a 2 in the front, it's going to double the original pattern. So what you really need to remember is remember this pattern right here. If you remember that pattern, then you can figure out what the actual values are, as long as you know the vertex. Okay, so now let's take something similar looking. We'll do j of x this time. Except this time we're going to do 1/2 times x minus 4 to the minus 3. So now we have to think in almost a different way. Okay, so this caused those numbers to double, right? Because it's 2 times 2. Then you can take a guess as to what this number is going to do. It's going to cause those numbers to shrink, to go the other way. So for instance, let's just do, let's just say it was 1/2 x squared, just like this, okay? So if I put in 0, 1, 2, 3, 4, we're not even thinking about the minus 4 and the minus 3 right now. If I put in 1/2, if I have 1/2, 0 is just 0. 1, well, it's just going to end up being the 1/2, because 1 squared times 1/2. Then 2 squared is 4 times 1/2 is 2. 4 squared, sorry, should be a 3 here. 3 squared is going to be 9 times 1/2, well, that's 9 over 2. And then let's add one more point in there. 4 squared, 16 times 1/2 is 8. So if you notice, again, it basically divided all those points in half, because it is a half. So now let's do that particular one. Now remember, this vertex starts here at that same point here. Okay, but then we're going to go in a different direction. So now, instead of going right 1 up 1, it's going to be only like 1/2 right in the middle. Okay, then the next one would be up 2 when usually it was up 4. We follow that same pattern. So here it's not up 4, but it's up just 2. And then to the right of that, it would be up 9/2, which is about 4.5. So it's 4 and right there in the middle, half. And the last one, it goes up 8. So from here, 4, and then we go up 8. 1, 2, 3, 4. 1, 2, 3, 4. Okay, and then again, reflect it over to the other side. Oops, over there. Okay, and then there is our graph. You notice that got wider this time. Okay, because again, the number on the outside, this causes a compression, so you're like squishing it, and it's kind of getting fatter. Okay, so that's the whole idea behind this. I'm going to go ahead and stop there. We can review more on Wednesday. I'll see you guys.